Hi students, welcome to my channel Excellent Ideas in Education. Today we are going to solve this problem. Draw a shear force and bending moment diagram for beams as shown in the figure. You see in this figure, 4-point load is given. A, B, C and D. One UDL load is given between B and C. Now we will convert UDL into point load. First we will draw the free body diagram. First draw the line UDL into distance. UDL is 2 kilonewton per meter into distance is given as 4 meter. 4 2s are 8. So 8 kilonewton. So how we will take the distance in this case? B by 2. UDL is B by 2. B is this length 4 divided by 2 is 2 meter. So we will take here to here is 2 meter. Here to here is 2 meter. Here is the point load is 8 kilonewton. Here is 7 kilonewton. Here is 8 kilonewton. Arrow comes down. Arrow goes up. A, B, C, D. This distance is 3 meter. This distance is 3 meter. First, we will draw free body diagram. Already finished this one. Second, using equilibrium condition to find RA and RD, summation of f of x, summation of f of y, summation of moment. Third point, we will find SF calculation. Fourth point, bending moment calculation. Based on the shear force calculation, we will draw shear force drawing. Based on the bending moment calculation, we will draw bending moment drawing. Next, we will calculate equilibrium condition. Summation of f of x. You see this graph, x-axis is in horizontal, y-axis is in vertical. You see in this FBD drawing, any horizontal force is there? No, right? Only vertical is there. So we will take only y. Summation of f of x, no force is there. So you can neglect this f of x. Now we will take summation of f of y. Summation of f of y is equal to 0. You see the arrow goes up. Up is positive. Summation of f of x, all the forces are in vertical direction. You see the arrow goes up. Up is, you see, positive. Plus or A. We will write it as this is RA, this is RD. Next, you see this arrow comes down, this arrow also comes down, this arrow also comes down. So minus. So we will take minus 7, minus 8, minus 8. You see this arrow goes up. Up is positive. So we will take plus or D equal to 0. Or A plus or D is equal to 7 plus 8 plus 8 is 23. Next, we will calculate summation of moment A is equal to 0. We will take clockwise is positive. What is the moment rule? If you have applied moment in the point A, that force should be 0. The distance of point A is 0 and the moment also 0. So this force is 0. If you apply moment in point A, that force should be 0. The moment also 0 in this D point also. This A moment is 0. Next, we will take B moment. From here to here, you see the arrow comes down. Down is comes this way. You see, goes clockwise is positive. Plus 7 into. What is the moment formula? Force into perpendicular distance. What is the distance? 3. Next, you see the arrow comes down from here to here. Plus 8 into distance is 3 plus 2 is 5. Plus 8 into 5. Next, you see this arrow comes down from here to here. Force is 8. Perpendicular distance is 3 plus 2 5, 5 plus 2 7 plus 8 into 7. Next, you see this point, the arrow goes up. From here to here, you see anti-clockwise is negative. From here to here, perpendicular distance is 3 plus 2 5, 5 plus 5 10 minus RD into 10 equal to 0. 7 3s are 21 plus 8 5s are 40 plus 8 7s are 56 minus 10 RD is equal to 0. Add this 3, 117 minus 10 RD is equal to 0 minus 10 RD is equal to minus 117 RD is equal to 117 divided by 10 equal to 11.7 kilonewton. Now we will calculate RA in this equation. RA plus RD is 11.7 equal to 23. RA is equal to 23 minus 11.7 equal to 11.3 kilonewton. This is RA value. RA value is 11.3 kilonewton. RD value is 11.7 kilonewton. Next, we will see shear force calculation. In shear force calculation, we will use two rules. First rule is positive shear force. Arrow goes up is here is positive. Arrow comes down is positive. This is positive shear force. Next, second rule is negative shear force. Arrow comes down is negative. Arrow goes up is negative. This is negative shear force. This side is left side. This side is right side. Here is also left side. Here is right side. Now we will calculate shear force at point A. You see the point A, the arrow goes up. You see this is left side. Left side arrow goes up is positive. Positive 11.3 kilonewton. This is left side. Now we will calculate right side. Or now we will calculate right side. Arrow comes down. You see the arrow comes down. Right side is positive. Plus 7. Next arrow also comes down. Next arrow also comes down. All is in right side. Right side is positive. Plus 8. Plus 8. Next, you see the arrow goes up. This is right side. You see up is right side is negative. Minus 11.7. 8 plus 8 is 16. 16 plus 7 is 23. Minus 11.7 is equal to 11.3 kilonewton. What is the shear force definition? Algebraic sum of the vertical forces acting to the left or right side of the cut section along the span of the beam. Next, we will calculate shear force at B. Now, we will calculate shear force at B point. So, B point is here. You see, the arrow goes up. This is left side, right? Left side is positive plus 11.3. You see the arrow comes down. This is left side. You see left side arrow comes down is negative 7. 11.3 minus 7 is plus 4.3 kilonewton. Or now we calculated left side. Now we will calculate right side. Right side we will take this point load. Right side point load acts downwards is positive. So plus 8. Next arrow also comes down. This is right side. Right side is positive plus 8. Next the arrow goes up. Right side. You see right side arrows goes up is negative. Minus 11.7. 16 minus 11.7 is equal to 4.3 kilonewton. Next, we will calculate shear force at C. Now we will calculate shear force at C. This side is left side. You see the arrow goes up. Left side is positive. Plus 11.3. Next arrow comes down. Left side down is negative. Minus 7. Next also comes down. Negative. Minus 8. Next also comes down. That is also minus 8. 11.3 minus 23 equal to minus 11.7 kilonewton. Or now we will calculate right side. Only one point load is there. It goes up. Right side it goes up is negative. Minus 11.7 kilonewton. You see the UDL load is there, right? So we will calculate left and right side. Right side already calculated. So you can take up to this is right side. This is left side is up to this portion. So we will calculate up to this portion. Right side is we will calculate up to this portion. Already we calculated right side at point C. Now we will calculate shear force at C left side. You see this point load goes up. Up is positive. Plus 11.3. Next you see the arrow comes down. Down is negative. You see down is negative. Minus 7. Next you see the arrow comes down. That is also negative 8. 11.3 minus 7 plus 8 is 15. 11.3 minus 15 is minus 3.7 kilonewton. Next, shear force at D. You see the arrow goes up. Up is positive. Plus 11.3. You see the arrow comes down. Arrow comes down is negative. Minus 7. Next also comes down. Minus 8. Next also comes down. Minus 8. You see the arrow goes up. Up is you see positive. Plus 11.7. 11.3 plus 11.7 is 23. Minus 7 plus 8 plus 8 is 23 equal to 0. Now we will draw shear force drawing. You see shear force at A is 11.3 plus 11.3. This is as a plus 11.3 kilonewton. Starts from 0 plus 11.3. Next B. Shear force at B is 4.3 plus 4.3. So this is 4.3. Next shear force at C we calculated left and right side. First we will take left side. Left side is minus 3.7. So minus 3.7. So minus means it comes down only. You see right is minus 11.7. So 11.7 is comes here. 11.7. Next shear force at D is 0. Now join the line. This comes straight. You see here this is point load. Point load is constant line only. Comes down. After that you see here is UDL. From here to here is UDL. Join the line. After that this one comes straight only. After that it goes straight. Why it goes straight? You see this is also point load. Constant line only. After that join the line. This is also join from here to here. This is positive. This is negative. Next we will calculate bending moment calculation. First we will take bending moment at point A. Bending moment at point A and point D is always 0 only. So no need to calculate this one. A is equal to 0. Bending moment at point D is equal to 0. What is the bending moment? Algebraic sum of the moment of the forces to the left or right side of the section. Now we will see two bending moment rules. Clockwise, it goes anti-clockwise is positive. This is left side. This is right side. Positive bending moment. This is the first rule. We will see second rule. It goes this side is negative. Clockwise is negative. This is negative bending moment. This is second rule. You see this B point load, arrow comes down. From here to here you see clockwise. Clockwise right side is negative. -7 into moment is force into distance. What is the perpendicular distance? 3. Next, you see the arrow comes down only. From here to here you see clockwise. Clockwise is negative 8 into perpendicular distance is from here to here 5. Next, you see this arrow comes down. From here to here you see clockwise. Clockwise is negative -8 into perpendicular distance is 2 plus 2 plus 3 is 7. Next, you see the arrow goes up from here to here this way. So you see this way is positive plus 11.7 into perpendicular distance from here to here is 10. 7 3s are 21 minus 21 minus 8 5s are 40 minus 8 7s are 56 plus 11.7 into 10 is 117. Add this 3 minus 117 plus 117 is equal to 0. You see bending moment at point A left side is 0, right side also 0. Next we will calculate bending moment at point B. Now we will calculate bending moment point B left side. Left side from here to here you see arrow goes up. From here to here is you see clockwise is positive. Positive 11.3 into perpendicular distance up to B only 3. 11.3 into 3 is equal to 33.9 kilonewton meter. Or now we will calculate right side. From here to here we will calculate. You see the arrow comes down. From here to here you see clockwise is negative for right side. -8 into perpendicular distance is 2. Next you see the arrow comes from here to here is negative. Perpendicular distance is 4. -8 into 4. Next you see this arrow goes this way from here to here. From here to here you see right side is positive plus 11.7 into what is the perpendicular distance? Perpendicular distance is 3 plus 2 plus 2 is 7. 8 2s are 16 minus 8 4s are 32 plus 11.7 into 7 is 81.9. Minus 16 minus 32 is minus 48 plus 81.9 is equal to 33.9 kilonewton meter. Next, bending moment at C. This C point we will calculate now. From here to here, it goes clockwise. You see clockwise left side is positive. Plus 11.3 into perpendicular distance up to C. 3 plus 2 is 5 plus 2 is 7. Next you see this point load comes down. From here to here, left side, you see left side is goes this way is negative. -7 into perpendicular distance is 4. Next, take this point load from here to here. This is also negative. Perpendicular distance is 2. -8 into 2. 11.3 into 7 is 79.1 minus 7 fours are 28 minus 8 twos are 16 equal to 35.1 kilonewton meter. Next, R. Now we will calculate right side. Right side only one force is there. It goes up from here to here. 11.7 into 3 equal to 35.1 kilonewton meter. Now we will write bending moment at point B is equal to 33.9 kilonewton meter. Bending moment at point C is equal to 35.1 kilonewton meter. Now we will draw bending moment drawing. You see the first point, point A is 0. This is also 0. This is also 0. What is B point? B is 33.9. So this point is 33.9. This point is 35.1. Now we will draw the line from here to here. From here to here, draw the line. This comes parabola. UDL is bending moment always parabola. This is bending moment drawing. This is shear force drawing. B, C, D, A. B is 33.9 kilonewton meter. C is 35.1 kilonewton meter. You see here, this point we don't know. So how we will calculate this one? Now we will take, this is as X. This one I will draw here. This is X. This value is 4.3. 4.3. This value is 3.7. 3.7. You see, this is 90 degree. Here is also 90 degree. This is X means what is this distance? You see here is whole thing is 4. So we will write 4 minus X. We will write this is as a 4 minus X. Now we will calculate X divided by 4.3 equal to 4 minus X divided by 3.7. Cross this and this. 3.7x is equal to 4 minus x into 4.3. 3.7x is equal to 4 into 4.3 is 17.2 minus 4.3x. 3.7x minus comes this side is plus 4.3x equal to 17.2. 3.7x plus 4.3x is 8x equal to 17.2. X is equal to 2.15. Now this x value is 2.15. Now we will calculate from here to here. This distance is now 3 plus 2.15 is 5.15. This distance is 5.15. Now we will consider this is as a E point. This is E point. Now we will calculate bending moment at E. Now we will calculate bending moment at E. You see the arrow goes up from here to here. You see clockwise is positive. Positive 11.3 into perpendicular distance is 5.15. Next you see this point load from here to here. It goes anti-clockwise. Anti-clockwise is negative. Minus 7 into, what is this distance from here to here? You see 2.15 into 2.15. Next, point load. From here to here point load is 2. The distance is 2.15 minus 2 into 2.15 into 2.15 divided by 2. This distance divided by 2. Close the bracket. Next, 11.3 into 5.15 is 58.195 minus 7 into 2.15 is 15.05 minus 2 into 2.15 is 4.3 into 1.075. 2.15 divided by 2 is 1.075 equal to 38.5225 kilonewton meter. Now we will draw the E point here. E point is from here to here. This distance is 2.15. This is E point. So E point is 38.52 kilonewton meter. B point is 33.9, C point is 35.1, E is 38.52 kilonewton meter. Thanks for watching this video.